Okay, now let us come to the video number 2 on dielectrics. Here the small definitions are there, the polarization is there, polarizability is there, electric displacement vector is there, susceptibility is there, dielectric constant, some basic definitions comes into play here. Okay. The word itself as indicates that polarization means the orientation of all dipoles, the orientation of all electric dipoles in a particular direction, under the influence of external electric field is called polarization. That means initially all dipoles, how they are oriented here, in the random direction they are oriented. But when I apply the electrical field, all will be oriented in one particular direction. That is called as polarization. Just now I explained, minus plus, this is plus minus, like this. Here that is plus minus, all are oriented random direction. But when I apply the external electrical field like this, this is plus minus, you see it is arranged like this, minus plus minus minus plus minus plus, you see all dipoles are oriented in one particular direction here. This is nothing but polarization. That is systematic arrangement is there. This systematic arrangement is called as polarization. Mathematically, how to define that? It is actual definition of the polarization. Mathematically, it is defined as a polarization. Here, polarization equal to dipole moment divided by volume, that is dipole moment per unit volume. Dipole moment per unit volume is called as polarization. P equal to dipole moment is mu. This is volume is V. Don't behind the SI unit and know that. SI unit, how to remember? You see, what is the unit of dipole moment? Coulomb meter. What is the unit of volume here? Meter cube. So that 1 meter get cancelled. So that Coulomb meter square, Coulomb m minus 2. C stands for what? Coulomb. M stands for what? Meter. This is the unit of it is a polarization. Mathematically, how to define? Dipole moment per unit volume, that is. And some books they will define in different fashion. Polarization equal to polarization equal to N into what? Mu. They will define like this. What is N here? N nothing but number of dipoles per unit volume, that is per unit volume. What does it? Divided by volume. Number is it is no unit for it, and multiply by what? Mu. This also we can write. This also like this. That is also vector. If the right side quantity is vector quantity, then left side is also what? Vector quantity. Because N is a scalar. Any vector quantity multiplied by scalar, it gives what? Another vector quantity. This is about what? Polarization. Next, polarizability. Next one is polarizability. Here, when an electrical field is applied to the sample, right? When an electric field, when an electric field is applied to the sample, positive and negative charges, there is a displacement of positive and negative charge. Under the influence of electric field, external electric field, E. Right, important. External electric field. Here, this as a result, when it is separated, then what happens? What happens when they are separated now? That is the induced dipole moment, or else we can say that the induced dipole moment is directly proportional to electric field, E. Mu is directly proportional to what? Electric field. This mu equal to one constant I am writing. Here, make out the differentiation. This is directly proportional. I am writing one more quantity. This is also alpha. It is alpha into what? E. This alpha equal to, you can write mu divided by what? E. This quantity is called as in what? Polarizability. This is called as in what? Polarizability. Here, how much induced dipole moment is produced now? Of course, it depends upon the electrical field. But this quantity is there now, alpha polarizability. It is not same for all the materials. It varies from one material to what? Another material. I'll give one example. The teacher is same. The same teacher is visiting to this different the classes. Don't expect for the same teacher all the students are orienting towards the board with the same magnitude. I can't expect. For the B.sc3 is different, B.sc2 is different, and primary school it is what? Different. We cannot expect all, that is what? All students are orienting in one particular direction. How much their orientation is that now? This differs from one classroom to what? Another classroom. Like that, the value of this alpha is also differs from one material to what? Another material. Here what happens? Here this is talking about the polarizability for the non-polar molecules. In the non-polar molecules, the positive charges and negative charges are what? Superimposed. Now, when there is the external electrical field is applied, there is a displacement. One is positive charge and a negative charge. When there is a displacement artificially, there must be a what? Induced dipole moment. It is not only this one. Induced dipole moment is directly proportional to what? Electrical field. This mu is directly proportional. Make out the difference. This and this. This mu equal to alpha into A. This alpha is called as in what? Polarizability. That is. Then what is the unit of this? I'll tell you this. Yes. 1. Alpha equal to mu divided by what? It is. Mu unit, you know that? Coulomb meter. Recall one equation last year you studied. Force experienced with the charged particle in electrical field. F equal to what? QE. Then can I write E equal to F by Q? What is F here? Force. What is the Q is? Charge. It is the unit is what? Newton per Coulomb. That is here Newton per Coulomb. Then this C I will take the numerator. Then this becomes Coulomb square meter Newton minus 1. This is the unit of it. I think it is clear for you that is. This is the unit of what? Polarizability. Okay. Now, next definition is what? Dielectric constant and all that. Okay. What is dielectric constant? Now I will define it. Constant is K. or some books they will write epsilon r, relative permittivity. Epsilon r is nothing but a relative permittivity. In magnetism, we are writing mu r, it is permeability. In magnetism, it is permeability, but here in the electrostatics, it is what? Permittivity. Both are same. Epsilon r or k, both are same. Okay. What is the difference? K equal to, we can write like this, epsilon divided by what? Epsilon 0. Here, what is epsilon? Epsilon is the what? Permittivity of the given medium, Medium may be benzene, alcohol, mica, paper sheet, anything it may be, hydrochloric acid, any wax or something. What is epsilon naught is permittivity of free space. Students, please understand, of course, mathematically you can write it easily and also you will get the marks. What the meaning this permittivity represents is, for any material, it permits how many number of electric lines of force. It permits how many number of electric lines of force in a particular media. In air it is different. The same charge I will place it in the water. The number of lines of force enters. That is also what? Different. If I place the same charge in any wax, where number of lines of force, that is what? Entering is also what? Different. The term, the permittivity means it permits how many number of lines of force. This will be differs from one material to what? Another material. Here, epsilon naught is a standard quantity. Everything we are comparing with respect to what? With what? Free space. Everything we are it is free space. We are comparing with respect to free space. Just in order to make you to understand, I will tell you, suppose, of course, K equal to, suppose this is 1, permittivity of the air is actually epsilon naught is 1.006, say that it is 1 value, and the permittivity of the air, 1 something here, 78, what is it? For water it is 78, epsilon naught equal to what? 78 for water. It is for what? Air. What is the meaning of this? The permittivity of water is 78 times greater than the what? Air medium. 78 times it is greater than what? Air medium. This is the meaning of it. What is the permittivity of air is? 1. What is the permittivity of water? It is what? 78, 79, 80, it is there. It differs. And the meaning is, the dielectric constant, the meaning is what? How many times it is more than with respect to what? Air. Remember, student, this is a conceptual based question. They will ask you in the competitive examination and all that. The least permittivity is always 1, students. There is no medium in the nature which is having the density is less than 1. Which is having the density is what? Less than 1. There is no medium, that is. And also, you never get the value of K is negative value, that is. And suppose, conceptual based question. What is the dielectric constant of the air? If I ask the question, what is the dielectric constant? That means, it is everything we are comparing with respect to what? Air. I am comparing air with respect to what? Air only. It is 1 by 1 equal to what? 1 only. Dielectric constant of air is what? 1 only. There is given an example. Is there any material which is having the dielectric constant is what? Less than 1, 0.9, 0.8, negative? No, not at all possible. This is the lowest value of a dielectric constant. Lowest value of dielectric constant, value of K equal to what? 1 for which medium here? Air medium. Actually it is vacuum units. And what is the unit of it? There is no unit for it because it is the ratio. It is the ratio. Epsilon divided by epsilon naught is the what? It is the ratio and it has no unit and all that. This is the definition of the what? Dielectric constant. If you ask a question, define dielectric constant. It is the ratio of permittivity of the given medium to the what? The permittivity of the what? Free space or air or vacuum. And sometimes I will say that K is nothing but K and epsilon r. Both are same. In the calculation is important. That is epsilon r equal to epsilon divided by what? Epsilon. Therefore, epsilon equal to epsilon 0 into what? Epsilon naught. This is epsilon is what? Any medium. Any medium. It may be any liquid, hydrochloric acid, benzene, what it may that is. And epsilon naught is the permittivity of the what? Air or vacuum. It is the what? Relative permittivity. It is the subscript, students. And it has no unit. No unit. And negative value is not possible. K is negative. It is not possible. That's no negative value. For all materials, always the K is what? Positive. Always K is positive. And K is greater than or equal to what? 1 only. For standard value. For water, it comes around 78 to what? 80. Its value is lies between that. For air, it is 1.006. For paper, it is 3.5. Glass, it is what? 4 to what? 10 and all that. Next. Some books, they will define the definition of the dielectric constant in different fashion. For example, this is your parallel plate capacitor. This is the parallel. Here it is plus plate. This is the plus. And this is what? Negative. Now the distance between the plates is what? It is D. You are doing this time one experiment, charging and discharging of capacitor. Capacitor is nothing but this is the two parallel plates and all that. Here, what is here? Air is the medium. Here, air is fixed. In this situation, capacitance value C equal to epsilon naught into A divided by D. It is what? Capacitance of what? Air medium. What is A? A is the area. D is the distance between the plates. A is the area of the plates. Is a circular plate, rectangular plate, whatever it may be. Now I will put a dielectric material. Introduce dielectric material. Introduce dielectric. Introduce dielectric. Now I am putting the dielectric material. Distance between the plates is same and all that. This is positive. This is positive. And this is what? Negative. Okay. Now I will place a dielectric material. I will place it. Dielectric material. Dielectric material is nothing but what I told you? Insulators. Here in the insulator, that is what? There is a display because of this external electrical field. There is a redistribution of the charges will be takes place. There is a redistribution, realignment of the charges will be takes place. When this is positive, this will be what? Negative, 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 negative. Here it is negative, no? So that this is plus, this is plus, this is plus, 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 plus. Again they are bonded. Here there is a dielectric material where what happens is there is amount of the induced charges are produced on this dielectric material. That is induced charges I would call it as. It is possible as long as external electrical field is what? Present here. In this situation, it is a dielectric material. I don't know what is this value here. This I will call it the epsilon. Now I will write C of medium equal to epsilon into A divided by what? D I am writing. What is epsilon? The permittivity of the given medium. What is this? Air is there. What is this permittivity is what? Epsilon naught. Now this is equation number 1 and this is equation number 2. Now I will write C of medium divided by C of air. equal to this equation. Epsilon naught into A divided by D whole divided by epsilon into 1. I made mistake here. Epsilon into A divided by D whole divided by epsilon naught into A divided by what? D. Now see which factor get cancels now. Here this A by D, this A by D. What is left here? Epsilon divided by what? Epsilon naught. What is epsilon by epsilon naught? This also what? K here. Just now I said that. Epsilon. That means we can define dielectric constant K equal to C of medium divided by what? C of air. We can define in this fashion also. Earlier I said that how define? K equal to epsilon R equal to epsilon divided by what? Epsilon. In both ways, what? You can define the value of what? Dielectric constant. It is the capacitance of the capacitor filled with what? Medium. To the, that means divided by. To the capacitance of the capacitor where it is filled with what? Air, medium and all that. Here is this student, one important point. Here the whatever the induced charges is that not produced now, this value that is induced phenomena, this that is charge storage of this material now, it differs from one material to another material, that is one material to what? Another material, that is. That's a lot of research work is going on this. Earlier the mobile phones, some of the mobile phones you see that is if you use for few hours, all the battery will be drained out. If you use very advanced mobiles and all that, that where the battery condition is good. Here, that is for 2 days together, there is no need of fault. The recharging is not at all required. Where I think ampere hour, I think while purchasing the mobile and all that, you know the specification has given. The digital camera, that is 4.8 pixel, megapixel, 16 megapixel, and also you will look into that. What is the RAM? Okay, what is the ROM here, and how much memory device? Along with that, the important component in the battery, that is in the mobile, is what? Battery. The life of the battery is represented, capacity of the battery is represented by ampere hour and all that. Where if there is some mobiles, the no need for recharging is not at all required. That is for 2 days and all that. And some mobiles will specify the number of talking hours. We can talk continuously for 8 hours, 12 hours, 16 hours and all that. If number of hours is increases, that capacity of the battery is what? It is increased and all that. This is what the work is going on. Still today there is a lot of work is going on where the capacity should be good. That means the backup, whatever the backup you are getting in the mobile battery, it should be longer period. And also at the same time, that is the weight of the battery is also what? Should be what? Less. Recently this year, one fellow, the chemistry fellow who received the Nobel Prize for this dielectric materials and all that. Still that is a lot of things are going on, that is. Okay. Okay, leave it all these things here. Now I explained what is a dielectric constant and all that. One more that is a derivation is there, that is a electric displacement, electric flux and electric induction, that is electric displacement or electric flux or electric induction. That definition and one small derivation is there, that I will do it now in this video, that is.